Okay, so far in this unit we have looked at three different forms of a quadratic. I wrote down the first two as a review. So the first one we called intercept form, also known as factored form. The idea here is if it's in factored form, we can very quickly, easily identify the roots, or the x-intercepts. Then we looked at a form called vertex form, which is in a slightly different format, except this time we have a number on the end, which we call k, and then we have a quantity squared. Okay. The nice thing about this form is that we know the vertex is at h comma k. So we said you're going to switch the sign of whatever you see inside the parentheses and keep the number on the end as is. So you're not going to change the sign of that to get your vertex. The third form is called standard form. This should look familiar to you. You've seen it before. So there's some advantages of this form. All right, just like there were advantages to the first two forms. Well, to find the axis of symmetry equation, and you want to look in your IB formula packet, this is actually given to you. Recall that it's just negative b over 2a. All right, so you can see that we have an a and a b and a c in this so-called standard form of a quadratic. Okay, this is the one you're most used to seeing. So to find the vertex, recall that since the axis of symmetry lies on the vertex, we're just going to substitute the x value that we got from this formula into the function to find y. Okay, we've already looked at doing that with the other forms. To find x-intercepts, recall that's where y is 0. One option, if it's not factorable, is to use the quadratic formula. If you look in your IB formula packet, notice this is also given to you. So x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay? The y-intercept, which of course is when x is 0, if we go back up here, if we were to put a 0 in for x, notice that you're going to end up getting c every time. So the y-intercept will always be whatever that c value is. Okay, let's take a look here. And let me scan this up. Okay, let's take a look at a problem where we wish to sketch this. Okay, obviously no calculator. Notice it's in standard form. Okay, so, and it's also not factorable. Alright, so we're going to have to use our knowledge of the axis of symmetry, the vertex, whatever intercepts we could find to help us produce a sketch. So let's start with the axis of symmetry. We said the formula when it's in this form is negative b over 2a. So if we plug in, we're going to have negative 4 over 2 times 1, which is going to give us negative 2. So over here at negative 2, I'm just going to use a dotted line to represent my axis of symmetry. Okay, it's not a vertical asymptote like we saw in a previous unit, but we're just using that dotted line to represent that middle folding line, that middle line of symmetry that we know is going to go right through the middle of our parabola. So we know if we have the axis of symmetry, since the vertex will be on that line, we can substitute in to find our vertex. So we already know the x value. We need to plug in to find the y value. So y would equal, so I'm going back to my original function. I'm going to plug negative 2 in for x. Okay. So this is going to give us negative 4 plus 1, which is negative 3. So negative 2, negative 3 is our vertex. So I'm going to plot this point. Negative 2, oops, I'm over on this side. I just made a mistake with my axis of symmetry. Sorry about that. Should have gone on the other side. Hopefully you used a pencil. I don't feel like starting this video all over, so Sorry, you're just going to have to deal with it. You know, from time to time, like I always say, I'll be making intentional mistakes, and that was certainly one of them. Just to make sure you're awake and paying attention. You're right. So -2 and -3 is over here. So this is our axis of symmetry, and this is our vertex, -2, -3. Let's find a x and y intercept if we could. So let's start with the y-intercept. So to find our y-intercept, we know we're going to make x 0. Well, we said that's always going to just be this number on the end. So the y-intercept is at 1. So 0, 1 is where we have our y-intercept. Our x-intercept, we have a little more work to do for this. Okay, so we can see that this is not factorable. So we're going to use our quadratic formula. Okay, so -b would be -4 plus or minus the square root. B squared would give us 16 minus 4 times the a times the c all over 2 times 1. So let's clean this up. -4 plus or minus, we would have the square root of 12 all over 2, which, let me give myself a little more room. Come down here. So -4 plus or minus. Now radical 12 up to the side here, we can break this down into radical 4 times radical 3, which becomes 2 radical 3. So this would be plus or minus 2 radical 3 all over 2. From there, we can divide a 2 into each of these terms. If we do that, we're left with -2 plus or minus radical 3. So, of course, these are not integer values for our x-intercepts. We want to get a feel, if we're not allowed to use a calculator, we want to get a feel for the size of this. Alright, well, the square root of 3, it's less than the square root of 4, so we know the square root of 4 is 2, so the square root of 3 is something a little bit less than 2. So what we need to do is just approximate about what it's going to be. So we know it's going to be 1 point something. Okay, so -2 plus 1 point something, and then -2 minus 1 point something. So we're going to have, if we do the positive version, -2 plus 1 point something, that's going to get us closer to 0. And if we do -2 minus the square root of 3, so -2 minus 1 point something, that's going to be a little less than -3. Okay, so again, what we have here is -2 plus radical 3 and -2 minus radical 3. So this is just an approximation, so we could then draw our graph, draw our parabola, okay, symmetrical over the axis of symmetry, of course, and going through the vertex. Okay, let's go on to our next page. Okay, next we're going to look at a technique called completing the square. Now, this is a technique that's going to allow us to convert from standard form which, if you recall from a few moments ago, is y equals ax squared plus bx plus c, to what we call vertex form, which we said is y equals a times x minus h quantity squared plus k. Alright, so again, you saw this last year, so this is not completely new, but we will still go through the steps. The first step here, and we're going to list them simultaneously as we do the problem, is to calculate b divided by 2 quantity squared. So my b is negative 4 in this problem. So if I do negative 4 divided by 2 and then square it, I'm going to get negative 2 squared, which is 4. So because we're squaring it, it actually doesn't matter if it's positive or negative. We're going to end up with a positive result at the end. So that's the first thing you're going to do. You're going to calculate whatever your b number is, divided by 2, quantity squared. The next step is to add this onto the first two terms. Okay, so we have y equals. By my first two terms, I'm referring to x squared and minus 4x. So we have x squared minus 4x. So we're going to add this onto our first two terms. So I'm going to add my 4 there. Alright, I still have this plus 3 hanging out there on the end. So my third step is to balance what you added. In other words, I can't just randomly add 4 onto this equation. I need to subtract 4 to balance out what I did. Notice that if we were to look at this entire new equation that I wrote, it's equivalent to what we started with. I have a plus 4 and I have a minus 4. Okay? So you might be wondering, well, why do we bother to do it then if they're just going to cancel each other? That's a real good question. So the next step is to factor the first 3 terms. And what you're going to notice is that you will always be able to factor this as 2 identical factors, all right, if you did it correctly. So you want to factor the first 3 terms, and then after that you want to simplify. So by that I mean we want to take what's left over here, this 3 minus 4, and turn that into negative 1. And since we have 2 identical factors, which again that's going to happen every time, we can express it as a single quantity, a single factor of x minus 2 squared, and then minus 1. So this is now in vertex form. I encourage you to put this equation into your calculator in y equals, as well as the original equation, and graph them at the same time. And what you'll notice is that you're getting only one graph to show up. That's because they are identical. It's the same quadratic, but just written in a different form. Okay? So if you had to find the vertex, here it would be positive 2, negative 1. Recall, you switch the sign of what's on the inside, but you keep the one on the outside as is. Let's do one more. This is the most complicated type that you're going to see. So notice now you have a 2 in front. So what we do in this scenario to get it ready is we need to factor out a 2 as a GCF, but we're just going to do it for the first 2 terms. Okay, we're going to ignore that plus 1 on the end. So if I factor out a 2 as a GCF, so this is my GCF, okay, if I take out a 2, I'm left with x squared minus 2x. I'm now going to close my parenthesis and write plus 1. Notice that if I were to distribute, I have not changed the problem. It's the same thing that we started with, 2x squared minus 4x. Again, I'm talking about distributing there. You get the same thing. So what we're going to do now is we're going to just drop this 2 down in front. We're going to bring it along for the ride. And then you're going to do the complete the square technique that we described in the previous problem on what you see here on the inside, that x squared minus 2x. So this x squared minus 2x, we're going to bring that along for the ride, and off to the side we have to calculate that b divided by 2 quantity squared. Alright, it's not necessary to do the calculation off to the side like this. You could certainly just do it in your head, but I'm just showing the work, just to show you where it comes from. So you have this 1 as our answer, so that's going to be added onto the first 2 terms like that. Now we have this other 1, which I'm going to just drop down. So now what I need to do is balance out what I just did. Well, it looks like I've added 1 onto the problem. Well, in fact, I've actually added more than 1. I've actually added 2 times that 1 because this plus 1 is inside the parentheses with a 2 on the outside. So what that suggests is to balance it out, we need to subtract 2 because we've really added 2 onto the problem. Again, how have we added 2? Well, it's really being magnified. This 1 is really being magnified by that 2. So from there, bring down that 2 in front. Remember, this trinomial will always be factorable. You'll always be able to express it as 2 identical factors. So you would really have an x minus 1 times another x minus 1, which we can just write as x minus 1 quantity squared. Combine these two, you get a negative 1. Okay? So this is our quadratic in vertex form. Okay?